All right, we are going to do lesson 4.4, an introduction to trigonometric equations. And really this is not an introduction, it is more of a continuation of trigonometric equations. Out of the sake of interest, I'm going to change this question to be like so. And I know that you've solved this question before, but it's really good to remind ourselves. Really what this lesson is about is interpreting the question correctly. So we're looking for 5 cosine theta plus 3 is equal to 0. Since we're going to solve the trigonometric equation in the given domain, since the only unknown in the question is theta, I'm going to solve for theta. The first thing I need to do is I need to isolate cosine theta. So I'm going to start off by subtracting 3 to both sides. And then I'm going to divide both sides by 5. So I'm looking for really where the cosine of theta is equal to negative 3 over 5 in the domain from 0 to 2 pi. I recognize that cosine is negative in quadrant 2 and quadrant 3. Further, cosine is equal to negative 3/5 is not a special angle. So this implies that I'm looking for theta in this interval, and I'm looking for approximate values. So really, I need to use my calculator. So cosine theta is equal to negative 3/5. I'm going to apply the inverse cos operation to both sides and jump on my calculator here. So inverse cos, negative 3 divided by 5, I get 2.21429 ... etc., etc., etc. So really, this angle is my quadrant 2 angle. I'm going to think of my quadrant 3 angle a little bit different. So a brief conversation is if you want to figure out quadrant 3, typically we ask ourselves, how far am I away from the x-axis? So quadrant 3, we would say, well, I would have to take pi and subtract this 2.21429 number. And then this represents how far I am away from the x-axis. So what I have to do is I have to go pi plus this amount. So I'm just going to add pi to the distance of where I am away from the x-axis, and this ends up being 2 pi minus 2.21429, etc., etc. But I'm going to try to stretch your thinking just a little bit. Shall we? So I ask myself, isn't this where 2.214, and you can keep all the decimal places if you want. And then I'm going to reflect this in the x-axis, or I can conclude that this is where negative 2.21429 is. But if I notice, I'm not after this amount, am I? So really, I need to find an answer that's in the domain from 0 to 2 pi. So I'm having erasing issues here, I apologize. It's just not working. So really, what I could do is to get the angle that is coterminal with negative 2.214, is I can just simply add 2 pi. So theta is going to be equal to 2.214. I'm going to keep it to 3 decimal places. Or it's going to be 2 pi minus that previous amount. And what it is 4.069. All right, let's go on to example number 2. Example number 2 should be relatively in our wheelhouse. We just need to reorganize the equation. What have I done here? Well, I'm looking for x. Now, x is between 0 and 360. So one thing that we're changing is now that I'm calling an angle x, but my angle has to be between 0 and 360. So in my equation, I'm going to isolate for sine theta. I'm going to subtract 2 sine x to both sides. And I'm left with 2 sine x is equal to what? I'm going to divide both sides by 2. So really, I'm looking for sine x is equal to 1/2. This right here in my domain, I know on my unit circle, I'm looking for the sine value that is equal to 1/2 in degrees. So this is a special angle. So really, what are we looking for? We are looking for what angle has a sine value of 1/2? Well, that's the 30-degree angle family. So my quadrant 1, sorry, I should use the proper variable. My quadrant 1 answer is 30 degrees, and my quadrant 2 answer is 180 minus 30 degrees, which is 150 degrees.